Hello everybody, getting ready to do lesson 3.2 part 2 today of 6th grade math classwork. And you got 22 points on your classwork sheet. Have that out in front of you now. Students, put your name, date, period here on your phone, your tablet, your paper, your Droid, your iPhone, your Chromebook, your PC. And we're going to do identifying opposites and absolute value of rational numbers. Let's go right into our bell work for the day. And we got compare and order decimals. Order from the least to the greatest. Here's our example up here. So we're going to order these numbers from least to greatest. Use place value to compare numbers starting with ones, then tenths, then hundredths. So we got decimals. 7.32, 5.14, 5.16. So blank is the greatest, and then blank is less than blank, and then therefore the order is, and then the order will be here. And then compare these decimals down here, students. Teachers, I will let your students do, they should be able to do these up here, even though it is an example. Let your students do it. Give your students about 4 minutes, 3-4 minutes. See you in 3 and 4. Okay, welcome back everybody for today's bell work. Order from least to greatest, 7.32, 5.14, and 5.16. So which one of these numbers is the greatest? Wouldn't it be 7.32? Yeah. And then from the others, what is less than the other? 5.14 is 5.14 is less than 5.16, isn't it? So it'd be 5.14 is less than 5.16, and then the order would be from least to greatest. It'd be 5.14, 5.16, and then 7.32. And then down here, 8.86 is greater than 8.65, isn't it? Yes, because 8 here in the tenths, 8 tenths is larger than 6 tenths. And then down here, 0.732 is less than 0.75 because we have the tenths, the hundredths. So 5 100ths is greater than 3 100ths. So therefore, 0.732 will be less than 0.75 because of that. And that's 10 points. Right into our lesson for today. Absolute values of rational numbers. You can also find the absolute value of a rational number the same way you found the absolute value of an integer. The absolute value of a rational number is the number's distance from 0 on the number line. Remember that? Let's get into an example of that now. Example 2. The table shows average low temperatures in January in one location. So we have 2008 through 2012. Negative 3.2, negative 5.4, negative 0.8, 3.8, and negative 2. So during a 5-year span, find the absolute value of the average January low temperature in 2009. So what would that be? Now these are all January temperatures, students. So find the absolute value of basically what? Negative 5.4. What's the absolute value of negative 5.4? So step 1, graph the 2009 average January low temperature. So that'd be down here. This is our thermometer here. Here's 0, and then negative 5.4 would be about down there. So 2009. Yeah, so the 2009 average January low is negative 5.4 degrees centigrade, which is about there. So graph a point 5.4 units below 0, which we've already done, is already there. So how do you know where to graph? How did you know where to graph negative 5.4 on this here? How in the world did we know where to put that? So negative 5.4 is between negative 5 and negative 6. So here's negative 5, here's negative 6. So here's 5.4. It's between negative 5 and negative 6, right? It's negative 5.4 is negative 5 and 4 tenths. So if you put 4 tenths down here, divide it up in tenths here, 5 tenths to be actually halfway between them, and then 8 tenths to be down here, etc., like that. So it's between, we know it's between -5 and -6. Since 0.4 is less than 1/2, it is a little closer to -5. So it's slightly closer to -5 than -6. Step 2, find the absolute value of -5.4. So -5.4 is what is the distance here between 0 and -5.4? Is 5.4, isn't it? The absolute value of -5.4 is 5.4. Okay, so it's time to think about just what we've done in the previous year, communicating mathematical ideas. What is the absolute value of the average January low temperature in 2011? How do you know? So again, the average low, if you go back to the table, you will find out that the average January low in 2011 was 3.8, right? It is positive, it's a non-negative, so it doesn't show up as a negative. But how far is it from 0 again? It's 3.8, right? So the absolute value is the distance from the origin. In this case here is the number itself. It's 3.8 is the absolute value of the January low and in temperature in 2011. Okay, so let's try some on your own. Graph each number on the number line, then use your number line to find each absolute value. So we have for 4 and 5, and we have 6 and 7. So we have -4.5 here. And then, so what would be the absolute value of -4.5 would be the question. Same thing for 1 and 1/2. Same thing for 4, same thing for -3 and 1/4. So graph each number, graph each one of these on the number line, then use your number line to find each absolute value, students. So first, graph each of these on the number line. Teachers, give your students about 5 minutes to do this, and then we'll check back with the solutions. Okay, everybody, welcome back for the solutions today. Graph each of these first, students, on the number line, and then use your number line to find each absolute value. So 4.5, first of all, -4.5, the absolute value of -4.5 be 4.5, and the absolute value of 1 and 1/2 will be 1 and 1/2. And then the absolute value of 4 would be 4. Then the absolute value of -3 and 1/4 would be 3 and 1/4. And then this would be your plots here. -4.5 would be here. So how far is it from 0 here to -4.5? It would be 4.5. And then for 5 here is 1 and 1/2, which would be here. So how far is it from 0? Even though it's to the right now, it's 1 and 1/2. So that would be your absolute value. And then for 6, 4 would be out here. How far is 4 from 0? It's 4. So that would be your absolute value would be 4. And then -3 and 1/4 would be here. So what's the distance between 0 and -3 and 1/4? It would be 3 and 1/4. So that would be how you would find your absolute values. And that's your lesson for today. Animated PowerPoint math video at AOL.com for questions or course materials. Thank you very much.